Okay, so we're recording now. So I'm gonna go back to the screen share, just so that's captured on the recording. Okay, so that's the typo. And so what I'm going to do now is just go over that, but I'm going to do it on using the document camera because I think that works better. Okay. Okay. So hopefully you have the handout in front of you, and the sort of I'll go over the setup. And so you have a square that's 100, so 10 by 10. And then that's going to be made up of two smaller squares. If you add them, not made up of it, but if you add two smaller squares together, you'll get this, you should get 100. So 10 by 10 is going to be, the area is going to be 100. Okay. And so this square, I'm going to x1, this square would be x2. Okay. And so we would solve something like this. 100 equals x1 squared, x2 squared. And as an equation, it has lots and lots of different solutions, infinitely many. Okay. But so here's a solution that they have. Here's what they have in mind. That they're going to say they're going to find a particular square. So they're going to start again 100, and then let's say the first square has side 1, and the second square has side 3/4. Now, we're using the method of false position. This guess isn't going to work. And remember before, we were solving the equation 4x plus 1 over 4x equals 15. We guessed 4, and we got, I'm sorry, I have that wrong. It was x plus 1 over 4x equals 15. We made a guess of 4, and so for x, and so we had that equaling 5. And then we said to solve this, we kind of use this, that the real solution over the guess, which was 4, is equal to the real answer over the number that we got, 5. And so what we had, that was a factor of 3. And so we just realized that the real solution was going to be 3 times 4, which is 12. And you can check it. And I'm not going to bother to do that. So that's what we did. So I want to kind of look at this in the same light. So here's the guess. So our guess is the two guesses are 1 and 3/4 for our sides. I'll call them S instead of X. Okay. And so what we get is we get 1 plus 3/4 squared. And that should be, it's going to be 1 plus 9/16. And that's going to be 25 over 16. Okay, so this is going to be analogous to that. And so the idea is that we had a guess, and the area that we get is going to be equal to 100 over the area that we got with our guess. So it's a little bit different, but the same idea. So we took it, we made it, sorry, let me do that wrong. I did that wrong. The true solution that's what it's going to be. I wrote guess here by mistake. Okay, does that make sense? It's sort of the same idea. We took a guess, we got 25/16. What we really want is 100. Okay, I'm assuming that's okay. I haven't seen any questions yet, so I'll continue. So this 100 is going to, this quantity is going to simplify to that. The factor is 64. So we're off by a factor of 64. So, but we're dealing with an area. So that 64 is really, it's a square factor. And remember, so we want, but we're looking at a side. This is an area. the area is off by 64. That means the sides are going to be off by the square root of 64, or 8. So we take 8 times 1, and that gives us 8 for our first side. Then 8 times 3/4, and that gives us 6 for the second side. Now, does that work? If we take this square and add it to this square, do we get 100? I'll let you do the work. So does that work out?
Yes. Yeah, I think it does.
Yeah. And so the difference is going to be that the first problem, it was linear, and so we didn't have to adjust it. The wrinkle here is that we have a square, which is an area, but we're looking for the side of the square, so we have to take a square root. And so again, this is a problem that's all canned to figure out nicely. And it suggests that they had a good knowledge of the Egyptians of squares, and here it looks like the Pythagorean theorem, right? There, it looks like they're using that, and they had some discussion of the Pythagorean theorem, but we're not going to go into that. Okay, so I just wanted to go through that since we didn't finish it last class. I just wanted to make sure that we did. Okay, questions? Okay. So let me stop the sharing. I'm sorry, I'm not sharing. So what I want to do next is go to the breakout rooms, and for one of the rooms I'm going to use. I emailed the people that were in the third group, and I hope you saw the email. But one of the members is having a connection issue, so I'd like you to meet on Blackboard Ultra. So the people in group 3 who are, let's see, it's CG and let's see. So it's CG, Hannah, Abasar, and then Kikit. If you all could go log out here, go to Blackboard, log into group 3, your group 3, log into Collaborative Ultra, and I'll join you over there. We're going to try to see if that works better for the connection issues. Everybody else just stay in Zoom, and we'll break up in groups in Zoom. Because I want to be able to use the whiteboard. That's why I want to stay in Zoom if I can. Okay. So the next thing I'm going to do is create breakout groups. And I have to do these manually because I want to make sure we get the right people in the right groups. And so that'll take a second. And then what I'm going to do is jump over to Ultra and talk to those people. I'll let you start talking about your problem, and you can talk about how you might want to do your presentation, how you're going to communicate and stuff like that. But so let me make sure that I get these groups assigned correctly. Again, I have to do it manually. To do it in advance is a pain. And so it's just much easier to do it this way. So I'm going to form group 1. Paul, Nick, Bryce, and Daniel V. And you all are going to be in 4 when I open them up. Okay, breakout room 2, it's going to have the second group. So that will be Paige, Molly, Colin, and Daniel M. Okay. So now I'll go to the third group. That's actually the fourth group. Because the third group is going to be within Blackboard, and that's going to be Hannah, who's not here today, or she wasn't earlier, Eric, Jackson, and Emma. Okay. Okay. And then Kika, you want to go into Blackboard and open, join the group that's already in there? Your group, which is group 3. Okay. Okay, so I'm going to open all the rooms and you all can meet, and I'll be with you. I'll be with you in a little bit. Okay, it looks like everybody's here, but you can't hear me. Okay, I think somebody's missing. Who didn't show up? Daniel V? No. Who's your fourth?
I think it's Hannah.
Oh, Hannah, right? Hannah didn't. Okay, she's the one. Okay, I thought she was in a different group. I think Hannah's in a different group. Let me double check. Let me also turn off
and then he added one for ours, but it was the one from the second group. So I'm just curious if he has one that he wants for us, but he accidentally added it wrong.
Oh.
Let's see here.
Hello, Professor.
You're on mute, Professor.
Presentation as as a video or
I'm sorry, I didn't hear the question.
Like a video, you mean like you're trying to draw in a whiteboard and like show it as a video?
Wait a minute, what's happening?
yeah, so I think he gave us like two options. We can either present it in front of the class,
So we have
in
leakage
front of
tonight.
everyone, or we can do a video and just post it up to YouTube and then just show it to people.
I am going to leave. I know what's going on. That's funny.
I think you're on Blackboard and Zoom at the same time.
Yeah, it
I
shouldn't
can't
be.
really think of other like
That's-
ways to do it. Same as the YouTube video that I just watched.
Yeah.
That's really, really funny. Yeah, I had a Blackboard window open, unmuted, but it must be using the same internal mic and projecting to you too. So I just had to close it. I'll come back. That was funny. Okay. So I was going, why? I noticed it didn't sound
Yeah. I heard Kikid's voice and I was like, oh, that's the Blackboard group.
right. And it didn't like, I just had to figure out, I haven't used Blackboard since like last spring and I couldn't remember how to get out, and there's no exit, you just have to close the window. So like, I apologize for the delay, and I was looking at you all and I didn't see your voices moving. It didn't sound like any of you. And so it took me
All good.
slow in the update.
All good.
So you're group 4, and then you have the hardest one.
Yeah, that's what I figured.
So I'm going to use the whiteboard. I think that's going to be the easiest way to explain things. So I'm going to bring you all out back to the Zoom room. Okay. So that'll take a second. Let's see.
You can just leave the breakout room. I think.
Yeah, we could do that too.
You back with me? Oh no, I have to wait. This is bizarre. Never mind. Shoot. There's a Firesign. I don't know if anybody knows who Firesign Theater is. They're a comedy group, and they have a routine called, how can you be in 2 places at once when you're nowhere at all? And I completely lost track of where I was. I thought I was in the breakout room and had lost Eric and a couple of other people, but I was actually still in the breakout room and they had left and they were in the main room. So I was trying to find them and I wanted to bring everybody out. So what I'm going to do is put you back in the rooms, and I apologize for that. So I'm going to recreate all the rooms and I'll see you in a bit. Sorry about that. So people in room 3, I'm going to have to go. I'm going to have to break you out again, but I'll do it right this time.
We can just
Wait.
not join the room and stay
Yeah.
in here.
Good idea.
So wait, do we join this one or no? I'm
Stay where
confused.
you are. Yeah. And then I'll go tell Molly to, let's see. I'll go tell her that would work a lot better. Oh, she's okay. Here, let me go in the room. Yep. Did it break up the groups? Let's see.
You put us in the wrong groups.
It said recreate. Okay, that's all right. That happens. We'll get this right. I would say that 9/10 of the issues are with me, but that one wasn't. It said recreate the rooms, and I did, and it didn't. It randomized them. So, okay. So I'm going to form all the rooms again, and then I'm going to leave group 3 out so we can use the whiteboard. That's what's causing all this trouble. So, okay. And so because the rooms got created, I have to delete them and recreate them. So I'm sorry to waste your time.
Your Honor, he's making it seem like it's a way bigger thing than it was. Oh my goodness, what did he do? Tell me. Well, it was completely different, Your Honor. Yes, we were at this wedding. Everyone was very drunk. I went with my best friend to the hot tub at the hotel.
Are we getting bombed? Okay, so group 1, you're going to apparate back to your group. Group 2, your turn.
So we do join this one?
Wait, I'm not sure who's talking, so.
This is Daniel.
Oh, yeah, you should. Yeah, you want to go into group 2. Everybody that's left is going to be the people I want to talk to in the main room.
Okay.
Okay. That could have been smoother. I apologize for all that.
Oh, good.
Okay, so here we are. Good, okay. That took way too long, so I'm sorry about that. I guess somebody had their mic off. Okay.
Yeah.
Right, okay. Okay, so your problem is you want to think about it as the problem. You have the more complex one. Okay. The problem that you're solving is this is given and this is given. Sorry, length times width is C, length plus width is B, and it's going to be a version of this quadratic equation. And it's going to be a version of that. I mean, the coefficients might not quite match up, but we'll get to that. So that's where we're headed. So the idea is just think of it. Let's skip that for now, but think of it as this: that the two givens are length times width, length plus width. You have to find length and width separately. Okay, and what you have describes it and describes the problem, but I think it's kind of, there's a lot of good information in that book, but it's kind of complicated. So what I'm going to do is I'm going to draw a line and then break it into length here and then width here. I'm going to give you an algorithm that literally completes the square.
Is this the right problem?
You're doing,
Because aren't we doing the Babylonian with the base 60?
no, this is your presentation problem. So your presentation, your group 4, right? Yeah, so if you go to the presentation projects in group 4, it'll have what you're supposed to be looking at.
So my question for that is, in here you posted a handout for the length width problem.
Yep.
Which is that? I thought that it says that's group 2 though.
Yeah, it's the same one as Group 2 has.
It's a different one than Group 2 has.
Is it?
Yeah.
Oh,
They also have they also have a length problem, but they're doing a completely different thing with it than you are.
Yes, but you posted the exact same document in both of our things.
I'm looking at Group 4 and I see reading material and I see 3 pages. And then I see Babylonian handout and Babylonian length width.
right. That's the same PDF that's in Group 2's
And I'm
material
looking
as
at
well.
Group 2 and I see a new way to do a quadratic, which is a video. And yes, I see that same handout.
So
So-
ours is just
Okay.
the reading material, or
But you have different reading material.
okay.
And you're going to be doing something
Oh.
different than what they're doing.
So okay.
Okay, and that's what and it's harder because I don't think the reading is the clearest way. So what I'm doing is going through the reading to explain what you're doing. Okay. Does that make sense? It's the same problem, but we're looking at it. They're doing something very different than you're doing.
So we're just solving in different ways the same problem. Okay.
Looking at it from different points of view. Okay. There's this new way to solve the quadratic equation somebody came up with a year or two ago that got a lot of buzz, but it's actually really what we're learning here. They're going to present the new way in modern terms, and then you're going to do a solution, a derivation of it by completely by pictures. Okay. Does that make sense? Yeah, okay. Okay, so what I'm going to do is you're given length times width, and think of that as C, and you're given length plus width, and that's B, and then you need to find L and W. And this is a procedure that will allow you to do that geometrically. Okay. So I'm going to draw the rectangle length times width here. So this is W and that's W right there. Okay. Now, what I'm going to do here is I'm going to have L plus W. So B over 2. And that's going to go to here.
Do you center the page a little bit more on the dock camera?
Yeah, let me get the, I don't have
Thank you. There we go. Yep.
Okay, you seeing it now? Yeah. Okay, let me raise this just a little bit so we can get it more in there. Okay, good. Okay. So what I did here is I'm looking at this part of it now, which I'm dividing that by 2, but the length of the side is still L. What's this equal to right here? Remember, the length from here to here is L. That's L plus W over 2. You should be able to figure out what that is by looking at L minus L plus W over 2. And so what do you get when you solve that?
L minus W over 2?
Exactly, right. Now, notice that if we know that, we can add that to and figure out, we can add that to this, which is known. This is just B over 2. That's known. This, if we find out what it is, we can solve the equation. Like if this were 10, sorry, if this were 10 and we find out this is 2, then we would be able to find out length. Half of length plus width, which would be 5, plus 2 would be 7 for the length, and then the width would be 3. Right, so does that make sense? Yeah. Okay. Okay. Now what I'm going to do in the next step is I'm going to add this, I'm going to move this from here over to here. So I'm going to flip it like that. I'm going to remove it from there, and then put it over here. Remember this is L minus W over 2 here, and this right here is just the width. And again, if you get stuck at any point, so this is no longer here. This part of the square is gone. I mean, this part of the figure is gone. So this is my figure. And notice that okay. Remember, the original square is L times W, that's equal to that. So I just move things around and I still have L times W. So again, if this were equal to 10, and this were equal to, I don't know if this is going to work, let's say, these numbers may not work out because I'm making it up, 8, then this would be equal to 4, L plus W over 2 or B over 2. Width is unknown, L is unknown. This length times width would be equal to C, which is 10. Again, we don't know what L minus W2 is. Once we do, we can solve the problem. I'm gonna like, I don't want to keep those numbers around because they may not be right. Okay, so I know, so what I want to do is complete the square. And so I'm going to complete the square by adding something here. Adding a little square to complete it. Now this is an equation. So if I add something here, what do I have to do to the other side?
Add it as well.
I have to add it. So I'm going to have to add my new square here. So I'm just going to go like this. Okay, and we'll figure out what that is. Now, what is this equal to? Remember, here to here is width, right? Because this side was width. We put the width here. So we know from here to here is width. From here to here is L plus W over 2. So what's this equal to? That's going to be, it's going to be L plus W over 2 minus W. So what's that equal to?
Is it L minus W over 2?
Nice. Because that means what we're adding is indeed a square. Because this side is L minus W over 2, and so is that. So the square that we're adding is L minus W squared over 2, sorry, over 2 quantity squared. So that's what this is too. So notice that we have over here, we have the original, we have a square now. And what are the dimensions of the square?
L minus W over 2 squared.
Square.
Oh. The whole square?
Yeah, this from here to here and here to here. What's this side and what's this side? They should be the same.
They both be over 2 technically?
Yeah, so we have L plus W over 2 squared is equal to length times width minus length minus width squared over 2 quantity squared. Now notice I can solve for this. This is what I need. This is given. This is B over 2. This is C. So this is my unknown. And remember, if I solve for this and know it, I can add it to B over 2 and get my length. And then I can add it to, I can subtract it from L over L plus 2 and get my width. So the key idea here is just to remember that length is equal to the half of the length, the average, plus this little piece. And the width is equal to and that's what we showed up here. So if I solve this, I bring the C over to this side, I have a square here, right? So I can take a square root. And that's what I have. So it's complicated, but it takes a couple times. I'm going to review it again. I start with my original length times width. That's the rectangle. I'm given L plus W over 2, and so I divide by that. I know that half the average of the length plus width is going to be less than the length. Just by definition, it's going to be greater than the width. What I discovered is that my length is equal to the average plus L minus W over 2. The width is equal to the average minus that. Okay. So then I know that, so I'm going to cut off this rectangle here, and I'm going to move this piece over to here. So again, this is no longer here. And then I realize that I'm missing a little piece here. I don't have a square. I figure out that this dimension is L minus W over 2, and so is this one. And so I add that there. Now I have a square. But I also have to add it to this side because it's an equation. And then I go back to what I'm given, and then I'm thinking that I'm given L times W is C, L plus W is B, and then I can turn that into this equation right here. And then I solve it, and that should look something like a quadratic equation. Okay. So what your job is to show that you can solve this without the numbers using this derivation getting down to here. Okay. And it's what it really amounts to is a geometric solution of the quadratic equation. I'm going to do that part of it, unless if you want to do that for a bonus. But I'm happy for you just to get to this point where you can present this to the class. And when you present, the way I want you to present it would be that you each do that you kind of share the presentation. You could do a video, you can do it like with you can do it with slides or whatever, and we can talk more about this. So I'll leave it to you to figure out how you're going to do it, and I'll be happy to meet with you again to talk about it. It's kind of a weird way to look at things, but once you get it, it's not that hard. It's just kind of hard to get to the point where it makes sense. And if you'd like, I can scan this and email it to you, or you can take a screenshot of it, whatever you want to do. But I'll scan that and email it.
Okay.
One of the other groups is talking. I'll let you stay in the main room, and one of the other groups is talking, so I'm going to go and see how they're doing.
Okay.
Okay.
Thank you.
Okay.
The solution, I mean, they get to one of the right answers, but it. Hi, Dr. Alexander.
Yes.
Hello. We are very confused.
Okay. Tell me what you're confused about. Looks like you did pretty well.
Because we could solve it like how we would solve it.
Right.
We don't understand how they arrive at their the process that they do, because that makes no sense at all.
Wait for group 2 to present. These are all interlocking presentations.
Okay, but how are we supposed to understand and present on if we don't understand it?
What you're going to do is go give this problem. You don't have to understand why. This is a quadratic. You can write the quadratic, right? That this is.
Yeah, that's what because we have it all written out like in the quadratic. If you see what we're sharing.
And they're right, exactly. And then I think you've done all the work you need to do. They're walking through the solution, and that's all you need to do.
So we really only just present this and then leave it to them to kind of fill in the blanks.
They're going to show where this comes from. Your job is to show that this is what they did. This is a quadratic equation solution. You're going to show how it matches ours, and you're going to tell me why they only gave one answer.
Is it who wants to say it?
Is
Go
it
ahead,
because
Bryce.
they didn't have negative
Is
numbers?
it because they? Oh, yeah.
These are physical magnitudes, and it took a long time. Even today, when I don't think I had any of you in calculus. No, I didn't.
No.
I haven't taught it since you were here. So I'm really a big stickler on things like speed and distance are positive quantities. Displacement and velocity can be positive or negative. Think of
Because
that.
their understanding is a magnitude.
Yes, a magnitude with a direction. This only has a magnitude. The way that most cultures thought of numbers were as magnitudes.
Uh-huh.
And so it's very hard to have a negative magnitude. Formally, it's easy, right? But it's conceptually, it doesn't mean anything until you expand your kind of knowledge of. I mean, how you present things.
How are we supposed to explain the given solution, though?
You just say, this is, pretend that you're reading this as if you're a Babylonian. They're telling you what to do. You do it. You solve the answer. Why does it work? Well, because you showed they're solving a quadratic and that this matches. So we know that it's correct. You don't know how they figured it out.
And so group 2 is going to explain how they figured it out.
Exactly.
Okay, so that's the
Okay.
presentation kind of a structure. We just say this, you just kind of say it, and then
And then we
say
just work through the
this,
quadratic equation.
and then this.
Yep. And then make sure you say about the negative.
Yeah, about the negative.
And then
Uh-huh.
here's something for you to think about when you present. Could you learn this way? And do you learn this way? Is this how you learn things? Do you learn by looking at a theory and using a theory, or do you do examples and figure it out from the examples?
I think both, because we don't understand what they're doing.
Right, but if you did this 5 times, could you reproduce it?
Eventually.
Yeah.
Yeah.
More than 5, but
This is thought to be a textbook problem. And so,
Okay.
so think about this as they're teaching you. They don't, what does it say about the fact that they don't give you a formula? What does that suggest about them?
That they expect you to figure it out.
They didn't think in terms of these theory formulas.
Well, that okay. That makes sense.
They thought in terms of a procedure and algorithm.
interesting.
Okay. And then how did they figure it out? Well, some smart guy figured it out, right? You're just like the lowly student figuring it out. And like, you're like, imagine when did you learn this? In junior high school?
The quadratic?
Yeah. High school?
Maybe
Well,
middle school.
Probably middle school.
You were a lot younger than this, right? You are now, right? So imagine that you're there, you're just saying, okay, I don't care why this is true. I just want to get through these problems, and you do enough of these and you say, oh yeah, I got it. Okay. I don't need to do any more. I can figure out how this procedure works. That's kind of how it's thought that they were teaching.
Interesting.
Okay.
Not from like, this is the opposite of Math 101.
Not from an area of understanding, but from if you do it enough times, you'll remember how to do it.
Different sort of understanding, I might posit.
Okay.
Yeah. Yeah.
So they
No.
did have an education system though. Like they would send their kids to school and teach them mathematics.
Well, we don't know how the system worked. They found there's huge amounts of tablets, and they think that these tablets, the best solutions I've heard are that those tablets were learning tablets.
Mhm.
Okay. And that they were, and we'll see some other ones too.
Okay, cool.
Yeah. Does that help? I mean, you did all the work, and I love this because it's like, this problem, because it's like, I remember when I did this, it was like, this is a quadratic. How do they know it? How do they know it? And like, I had the same questions you did. And then the teacher went through what group 2 was going to do. And I go, oh, and the question, how did they figure it out? And we're going to see some different speculations on how they looked at the quadratic. You have the easiest one, but it's also the least satisfying.
Okay.
Yeah.
Okay.
Okay. But follow the implications of what it means for them, like not having a formula, doing it a procedure, this being something that you learn. Think about it, and don't be afraid to speculate. I'm not going to penalize you for not having.
Okay.
Yeah. Okay. And then I'll leave it up to you all to figure out how you want to meet. You have that Blackboard group that should work.
And around how long do you want the presentations to be again?
10 to 15.
Okay.
And if it's less than that, it's not. I want these to be kind of simple, the first ones. And if it's less, and then I'm going to let everybody do their presentations, and then I'm going to wrap it all up and try to tie it together.
Okay.
Okay. And so rather than me doing all this stuff, I'm just having you do it. That's kind of what's going on. And yours is the first step. That's why I gave it to you. That's why all random. First group gets the first step.
Okay.
Okay.
Cool. Well, thank you.
You're welcome. Yep. Okay, good. I'm going to go back to the other group. You can hang out and talk. I'm not going to come back to the class, or you can go. Whatever you want to do is fine.
Sounds good.
And I'll have some kind of group assessment where I'm just going to ask you, like, you know, my assumption is everybody contributes equally. And then I'll have like a rubric which you fill out that's brief that you can sort of talk about that. And if there is an issue in your group, with given who you all are, I'd be shocked. Just let me know before it becomes a big issue. If you know, if like someone's not pulling their weight or something, but I'm sure it's all going to work fine.
Sounds good.
Or if there's communication issues, you know, I mean, in terms of like bandwidth or something.
Yeah.
Okay. Okay. Talk to you in a bit. I'm going to go see the second group.
Okay.
Or the third group, I guess. Yeah.
So like 5 sessions, which is nice, but
Okay. So, and you are group 2, right?
Yep.
I believe so.
Okay. So did you figure out that new way to do the quadratic?
Mm-hmm.
And I assume, I mean, I hope, oh, you can't see this. I can do it here. I can do it with the whiteboard. Did you look at that length width problem?
Yes.
Do you see how the two connect?
Yeah, the wording is a little bit confusing.
Right.
And also the notation for like the 6 semicolon 30.
Yeah.
What do the semicolons mean?
Let me just show you kind of a couple things. Okay, so let me pull up the whiteboard. Okay, so if they wrote something like, remember they had a base 10, a base 60 system, so their numbers were like this. I'm writing a 2-digit number. That's A times 60.
Mm.
B times 60 to the first, plus C times 60 to the 0. I'm not going to write it. Oops. Decimal point, D over 60, E over 60 squared, etc. Okay. And they would write this number as A, comma, B, comma, or we would write this, not they. So that's supposed to be a semicolon. I think I make them backwards under the better circumstance. And so that's how you would interpret that number. So the number, the second decimal, you think of it this way, the first one like this, over 60. So let's look at 730. The 7 won't be a problem. So that 30, this is 730 over 60. Does that make sense? You can convert to 1/2. In fact, you know, switch them all to base 10. So, you know, and then let's look at 1033. I'll do a lot. Let's look at 1033. I don't think you have any 3-place decimals. That's going to be 33 over 60, the decimal part. Or it's actually sexagesimal. Sexa meaning 6, deca meaning 10, or sexa meaning 60, plus 45 over 60 squared. Hopefully that's a common fraction. And you have, so let's see. So how would you could use decimals, but this is what the fraction would be. Times 33 plus 45 over 60 squared. And why don't you tell me what fraction that is? I will do the same thing. I can't remember which one it is, but sorry, I don't mean to narrate.
No, it's fine. Is it 9 over 16.
Mm-hmm. 3/4 squared. So yeah, so that's why they get that. That's why it's, you know, they're squaring 3 1/4, and that's going to be 13. Let's see if we got it right. 13/4. That's going to be 169 over 16. Is that right? That's going to be 160 over 16 plus 9 over 16. So that's what you get, right? Yeah. Yeah.
Were you writing on the board?
Yeah, you can't see it though. I was just doing it on my own.
Oh, I see.
Yeah. I was just checking the work. Yeah, so this does equal 9/16. But remember, you're squaring, if you're squaring 3 1/4, that's what 315 is.
Mm-hmm.
And if you square, that's 13/4, and if you square it, you get 10 and 9/16. So in other words, 10, 33, 45.
Oh, I see.
Yeah. Okay. But you can use the you know, feel free to use the I mean, you know the numbers up here. If you look at the top, 6, 6.5, and 7.5, you can use those as the basis for your calculations. Don't do it base 60. I know you want to figure it out for yourself. Okay. So, and what I'm looking for with you is to, you understand. Can I erase all this? Everybody have it?
Yep.
Mm-hmm.
Clear. Okay. Okay. So this is the way I think of the video. Midpoint, they use U, right?
Yeah.
Yeah.
Do they use midpoint or do they use something else? This is the way that I think of what they're doing. And if you multiply this out, you get x squared minus m plus u quantity x. And then you get minus m minus u quantity x. Plus m minus u, m plus u. Okay. The way to think about this is going to be a length, this is a width, and this is length times width. So if we write this with a single x term, oops, let me get that right. That's how you would write it as an equation. This is length, this is width. Otherwise known as B, right? This over here is your C term, length, it's length times width. So that's your equation. And they say find length and width. This solution over here is going to be your length, and this is going to be your width. And that procedure that you gave is based on this procedure. because you're finding the midpoint in the solutions, right?
Right.
That's the midpoint. That's L plus W over 2. And so that's something that you know, so that's going to be given. You can find that out from the problem. You know, if you get an equation that looks like x squared minus bx plus c, and then you're given length times width. The procedure that you gave allows you to find L and W by finding the two x values. L is going to be the short one. I mean, the longer one. W is going to be the shorter one. So what I'd like you to do is sort of present that new method, and then say this is similar to the length width problem. And all you need to do is show, because we're going to have another, I'm going to talk about it and somebody else says, all you need to do, you need to show that new method, and then just show that if this is L and this is W, that it's solving the problem, the length times width is given, and the width is given. And if you look through that procedure, which you don't really need to do, that procedure is going to give you the answer here. Okay. So the thought about that new method is that, and I think they say it in the video, is it really goes back to ancient to this problem, and it's just kind of rediscovered. And so kind of what I want you to think about, I want you to present the new method, tie it into this, and think what it says about, like, do you like the new method or do you like the quadratic equation? Which do you think is easiest?
I think it depends.
Yeah. Okay. I like the new method. It's procedural. It's algorithmic as opposed to giving you a formula. So just think about how there are different ways of looking, of solving, really different ways. We have the formula quadratic equation. That's a different way than this procedure. It's more formal. It's more math 101. This is more practical. So I want you to just think about those things. And then when you present, you can present it in any way that you'd like. And I'll leave it up to you to figure out how to do that. And then I will give you, like, you know, I'm going to give every group sort of a rubric. I'm going to assume equal participation. I just want some feedback that that's actually what happened. And when you present it, I think it's good if everybody, like Daniel, you were in on the CS capstones.
Mm-hmm.
So you know how that works. That's kind of what I'm imagining this is going to be like. But it could be a presentation with slides that you do in class, or you could do a video so it's done. You don't have to think about it. And we'll just show the video in class. So however you want to do it. And I'll let you work all that out. I'm happy to meet with you again to explain things and to go over things. And we'll have some time on Tuesday to talk about these too. And then there's going to be all 4 presentations are going to come right in order, and they feed off each other. And then when you're done, I'm going to come on and try to tie them all together. And I'm going to talk about what this tells us about Babylonian mathematics. And I'm hoping 10 to 15 minutes. If that doesn't seem reasonable, if it's not long enough, definitely contact me. If it's too long, I don't think I'm going to worry. I just want to get the procedure down. So if this ends up being a little bit shorter than that 10 minutes, no worries, no penalty or anything like that. Okay. Does that give you enough to go on?
Yeah, I think so.
Okay, good. Because time's almost up, and I want to visit one more group just to tell them, the group I visited first, to tell them that they can go. But you're free to go if you have questions. Let me go talk to them, and I can come back if you have questions, or you can just go. It's up to you. But do you think do you think this will work? This is okay?
Yeah, this is good.
Perfect. Okay, good. Okay, so I'll let you be, and then let you think about it, and then if I see that you're still here a couple of minutes, I'll come back and say hello.
Okay.
Okay, I'll stop the share. You want me to? So I have a copy that I can scan that and email it if you want.
Yeah, that'd be great.
Oh, good. Okay, we'll do. Okay, talk to you later.
All right. Thanks, Dr. Alexander.
Have a good weekend, and enjoy your evening.
You too.
Bye-bye.
Okay. Oh, that man left so fast.
Cool.